In this video, we're going to look at the relationship between the graphs of exponential and logarithmic functions and how changing the basis of these functions affects the graph. I'm going to start with f of x equals 2 to the x. Here's my first point. When x is 0, 2 to the 0 is 1. The next point, when x is 1, 2 to the first power is 2. Next point, when x is 2, 2 squared is 4. The next point, when x is 3, 2 cubed is 8. And when I graph the function, I get my increasing parent graph, and I also, don't forget, get the horizontal asymptote of y equals 0. The inverse of y equals 2 to the x is y equals log to the base 2 of x. And I'm going to graph that here in blue. And here is my first point, 1, 0. Notice the key to inverses is switching your x and y values. So the point 0, 1 became the point 1, 0 on the inverse. Next one, the point 1, 2 became 2, 1. And then 2, 4 became 4, 2. And 3, 8 became 8, 3. So that gives me the increasing parent logarithmic graph. And it also comes with an associated asymptote, a vertical asymptote of x equals 0. Lastly, if I graph in the line y equals x that's shown here in a black dotted line, the graph of 2 to the x and log to the base 2 of x are reflections about this line. Now let's start changing the base. So I'm going to increase my base, and as the base gets larger, both functions are still increasing. The exponential function rises more steeply, while the logarithmic function rises more slowly. So now I'm going to bring the base back to where I started at 2. And now I'm going to reduce it even more, but I'm going to make sure it stays over 1. So as the base reduces, I still get increasing parent graphs, and they are still reflections about the line y equals x. So as long as the base is bigger than 1, I will have increasing parent graphs for both the exponential and logarithmic functions, and the exponential function will have a horizontal asymptote of y equals 0, and the logarithmic function will have a vertical asymptote of x equals 0. Now let's look at what happens when the base lies between 0 and 1. I'm going to start with a base of 0.5 or a half. So I'm going to graph in red f of x equals 0.5 to the x. I'm going to plot some points. So here are some points giving me my decreasing parent graph. But again, I have a horizontal asymptote of y equals 0. Now the inverse of this function is log to the base 1/2 of x. So if I start graphing that, log to the base 0.5 of x, remember we interchange x and y values, so 0, 1 becomes 1, 0. So plotting our other points, I get a decreasing logarithmic function with a vertical asymptote of x equals 0. And if I graph in the line y equals x, which is here in a black dotted line, you can see the red graph and the blue graph are reflections about this line. Now let's change our base. I'm going to keep the value of the base between 0 and 1. So I'm going to increase it up to 0.9, and then I'm going to decrease it all the way down to 0.1. And as you can see, in all these cases, I still have a decreasing parent graph, whether it's an exponential or logarithmic function. So in conclusion, if the base of my exponential or logarithmic function lies between 0 and 1, I get a decreasing parent graph, but if the base is bigger than 1, it will be an increasing parent graph.